Self-healing materials are a revolutionary class of materials that possess the incredible ability to repair themselves. There are two main categories of self-healing materials: autonomic and non-autonomic. One approach to self-healing involves the use of microcapsules containing healing agents. Another mechanism relies on dynamic covalent bonds, which can break and reform, allowing the material to heal itself. Supramolecular chemistry and non-covalent interactions, such as hydrogen bonding, also play a crucial role in self-healing materials. Specific chemistries like Diels-Alder reactions and shift-based linkages have been explored for their self-healing properties. Self-healing materials have numerous potential applications in the biomedical field, such as wound care, medical devices, and tissue scaffolding. In the construction industry, self-healing materials could be used to repair buildings, bridges, and other structures. While self-healing materials hold immense promise, there are challenges to overcome, such as catalyst stability, compatibility with different materials, and biocompatibility. Researchers are continuously working on advancements in self-healing materials, developing improved catalysts, exploring new chemistries, and implementing techniques like wax protection. Self-healing materials have the potential to revolutionize various industries, creating a more sustainable and resilient future for us all. Self-healing materials are a true testament to the ingenuity of human innovation, drawing inspiration from nature's ability to heal.